Hi, welcome to the video lessons for Newton's laws. I want to solve a few problems here. The first problem I have is a pretty classic problem. I think everyone knows the traffic light problem in physics. And with this problem, I'm going to figure out the tension in each of the ropes. So one thing about this problem that is assumed, of course, we always make assumptions in physics, is that this whole thing's not accelerating, right? It's staying still, so no acceleration. And again, that's because it's motionless. So what does that mean? The assumption we can make from this is that the sum of the forces in both x and technically both y must be 0. Now, it doesn't mean that there's no forces acting on our system. It just means they add up to 0, which actually helps us set up our equations. So what I'm going to do is draw a free body diagram of the traffic light. So the traffic light has a tension. I'll call this T1 here. And then this one is T2. I tried to draw them differently. So tension is a force. These are pulling it up. Without it, this would fall. And then, of course, itself has the force of gravity. Okay, so this would be an appropriate free body diagram of our situation. Just like that. So, as always, we're going to start by basically labeling our x and y. And we already know, like I said, that the force on our system has to equal to 0 for x and for y. So what I like to do first is, especially if I have angles like this, is just kind of visualize my x and y so it can help me with my signs. So, you can see T2, in order to make this angle, I have to go to the left, and I have to go up. Just like that. Now this angle up here is going to be the same as down here because of our lovely geometric property, alternate interior angles. So I have T2x here. So this is the tension in the x. And I have T2y, like that. Now notice that this is pointing left, so this is going to be regarded as a negative value, and this is up, so it's positive. And then same thing, I'm going to have a T1x and 1x, and then T1y. And then same idea, alternate interior angles tells me the angle here is 37. Okay, so let's start with the x. So I have two x's. I have this one right here, that's an x, and this one. So, and then I'm going to do the sign. So I have only two x's. Now notice I'm ignoring these because they're in two directions. I need to keep it in one. So I have T1x is going to be positive minus T2x equals 0 newtons, just like that. Now these are not necessarily the same. Well, I'll be careful. The T1 represents the tension and T2 represents the tension. These are not the same tensions, but their components will be the same, which I hope makes sense because this thing's not moving left or right, so these have to cancel. So that's our setup there. Now if you notice the y's we have 1, 2, 3 y's. And these are up, that one's down. So that will correspond to T2y plus, because it's up, T1y. Well, let's not make that look like a 2. Go. T1y minus force due to gravity. And that is most of the physics right there. Oops, there we go. Now what we need to do, of course, is we need to solve for both tensions. So we'll know that if I look at let's look at T1 right here. Hold on one second. So we look at T1 right here, and what we'll see is, let me just change this so it's pen, okay? Is that T1x is actually a component of T1, or in other words, I'm just going to do this right here. T1x is going to be T1 cosine of our angle. So for now, I'm going to use symbols, angle 1. So that's angle 1. And this I'll call angle 2, like that. And then T1y is going to be the hypotenuse times the angle, so T1 times sine of the angle, 1. Okay. And then similar method right here. And these are both positive because they're going right and up. This one's going negative and up, so these will look like the x's, I'm sorry, the 2's. I'm just going to write them over here. T2y is going to be positive T2 sine of the angle, 2. And T2x is going to be T2 cosine of the angle. Now, I already considered the negative sign right here, so I'm not going to be redundant always. It will make it add, and I don't want it to do that. So, but these are the values. So in other words, I can rewrite these, because as of right now, what I have here is, lots of unknowns. I don't know this, I don't know this. I don't know this, I do not this. I do and can figure out this because I do have the mass. So let me write this out in terms of all the stuff that I have right here. So this becomes, here we go, T1 cosine of the angle 1 plus T2 cosine angle 2 equals 0. So that's all of that. Ooh, negative. And then, as you can see, we have T1. If I move this over right here, cosine of the angle 1, I see that they must be, like we've already said, these have to be the same magnitude for these to cancel. So that's a really nice relationship right there. And then let's take a look at this. This is going to be T2 sine angle 2 plus T1 sine angle 1 minus, so FG, recall, is mg, where we have the mass, which is right here, and then we have g, because that's 9.81. And this is where we leave it positive, because we've already taken into account that this is a negative or acting down. So lo and behold, these are essentially what I'm going to use to solve for T1 and T2. Now, since we have 2 equations and 2 unknowns, we can solve this with a substitution. So when you have 2 equations, 2 unknowns, we can use substitution. If you use 3 equations, you must have 3 unknowns, you must use 3 equations substitution. So that's what I'm doing. As you can see, I'm kind of doing it right here. I'm actually going to solve for T1 by saying T2 cosine 2 divided by cosine angle 1. Now, just to make life easier, these are literally just numbers. So what I'm going to do is calculate these. Calculator's over here. Okay, here we go. So I'm just going to show you what I'm going to do is T2 cosine angle 1, which is our 37, divided by cosine 53. So cosine 37 divided by cosine 53. So T1 is going to be T2 times 1.3, let's do 33. By doing this, plugging it in here would be a lot easier. So, and then at the end I'm going to actually solve it with this. So I'm just going to rewrite this so it's nicer. T2, actually, let me write it with the number in front. So all I'm doing is just writing this nicer. So 1.33 T2, like that. Okay, so let's start with this one. Let's see, where do I have room? I guess I'll go to the side. No, I'll go down. I'll go down. Leave that up there. So what I'm going to do is plug in T1 into equation 2. If this is 2 and this is 1. Oops. 1. There you go. Here we go. So it's going to be T2 sine, I'm going to put in numbers now, sine of the angle of 2, which is our 53 degrees, plus T1, which we have is 1.33 T2 times sine of 37. So remember, this is all T1 minus 33 kilograms times 9.81. All equals to 0, like that. So let's reduce this down, because now we just have one unknown, which is the T2. So I'm just going to put everything into numbers, and then I'm going to move this over. So what we get is sine 53 is I get 0. This rounds to 8. T2 plus, so sine 37 times 1.33 gives us another 0.8 T2 equals, like I said, I'm bringing that over, 33 times 9.81, 323.73. So these add up to 1.6 T2 equals 323.37. And what I'm going to solve for now is T2, so I divide 323, divide this by 1.6. So I get a value of 202.33 newtons, like that. Very cool. So that's tension of the second one, which is, I defined as this one, so that was T2 right here. Now let's find T1. Well, T1, we have this nice relationship already, which is kind of nice, like I said. So T1 is going to be 1.33 times T2, which is the 202. Times 202.33. I get 269.1 newtons, like that. There we go. So, there we go, T1, T2, and we solved our problem. So we got the tensions for both of these. Alright, we'll do another problem in the next video.